When you hear the word cheetah, your mind goes straight to one thing.
Speed.
Just pure explosive speed. It's the ultimate biological sports car.
It really is. I mean, this is an animal built like a javelin, long legs, a tiny head, that huge tail acting as a rudder.
And a spine that works like
Yeah.
this giant flexible spring.
It's pure specialization. We're talking about an animal that can hit, what, over 100 kilometers an hour?
Yeah, about 65 miles per hour. But the truly jaw-dropping part is the acceleration.
No, absolutely. It's not just the top speed.
It gets there instantly, 0 to 100 kilometers per hour in roughly 3.4 seconds. I mean, if you were driving a high-end McLaren, you'd be impressed. For a living thing, it feels almost impossible.
And if you stop there, the cheetah is just this magnificent blur of muscle. But for geneticists, well, its speed is actually the least unusual thing about it.
Right.
Because this predator is walking, breathing proof that a species can survive and even dominate while carrying a crippling genetic debt. It's a mystery that, statistically, should have wiped them out ages ago.
Okay, let's unpack this mystery. This deep dive is all about how the cheetah became its own identical twin. And the story really kicks off in 1983 with an American geneticist, Stephen O'Brien.
Right. O'Brien and his team were looking into this really frustrating problem. Why cheetahs were so incredibly difficult to breed in captivity.
So they started testing them. They got samples from 55 South African cheetahs.
And they were just looking for standard genetic diversity, the random shuffling of genes that makes every individual a little bit different. What they found, though, was stunning.
It was so bizarre, O'Brien later joked he thought the technician had accidentally drawn blood from the same cat 50 times.
I can believe it, because they analyzed 47 specific genetic markers. These are called allozyme loci. And across all of them, the cheetahs were, they were genetically monomorphic.
Zero variation.
None. For context, if you test humans or even domestic cats, you'd expect to see variation in, say, 20 to 40% of those markers. The cheetah genome was a flat line.
So we're talking about a species where a cheetah in Namibia is genetically an immunological clone of a cheetah thousands of miles away in Kenya.
But, seeing that in the data is one thing. Testing it in the real world is something else entirely.
And that's where the skin graft experiment comes in. This is the definitive, absolutely jaw-dropping proof.
So normally if you take a patch of skin from an unrelated donor and put it on another animal, a mouse, a dog, the immune system goes on high alert.
Right. The major histocompatibility complex, the MHC, kicks in.
Exactly. It's the body's ID system. It screams, "This isn't me, reject it."
And the rejection is fast, like within a couple of weeks.
Usually, yes, because MHC genes are supposed to be the most diverse part of the genome. But in the cheetah,
They just accepted the grafts.
they let it heal. The grafts they'd integrate into the skin and sometimes last up to 78 days without any major rejection.
Wow.
Their immune systems were so similar, they literally couldn't tell the difference. They were, for all practical purposes, identical twins.
Which brings us to the core question of this deep dive. How on earth did a species with zero genetic diversity, a condition that causes catastrophic inbreeding depression, not only survive near extinction, but go on to become the fastest, most specialized predator on Earth? This is the ultimate genetic paradox.
Okay, so let's get into the evolutionary debt they had to pay to pull that off.
So this incredible uniformity, this sameness, it isn't a new thing. This is an ancient trauma.
That's exactly right. We're tracing a story that starts millions of years ago.
And not where you'd think.
Not at all. The evolutionary cradle for cheetahs was actually North America. Fossils go back about 4 million years there. Their ancestors migrated out and spread across Asia, Europe, and Africa.
So they were a successful group for a long time, but then they ran into two massive crises.
A double bottleneck that it essentially wiped the hard drive of their genetic code.
The first one was about 100,000 years ago.
Yes, likely tied to that long migration across Beringia. That creates what we call a founder effect.
Where a new population starts from just a tiny group, so they only have a fraction of the original genes.
Exactly. But the real hammer blow was the second event.
The late Pleistocene extinction.
Roughly 11,000 to 12,500 years ago. This was a global cataclysm at the end of the Ice Age. It wiped out 75% of all large mammals in North America. We're talking mammoths, giant sloths.
And the cheetah's American relatives.
Gone. The few cheetahs that survived elsewhere in the world came from a vanishingly small group of individuals.
And you can actually quantify the cost of that today. There's a whole genome sequencing analysis done in 2015.
That confirmed it. Cheetahs today retain only about 0.1% to 4% of the genetic variation you see in most other species.
Hold on, 0.1%, that number is shocking.
It is. To put that in perspective for you, that's less genetic diversity than you find in highly inbred domestic cats. It's less than what you see in the Tasmanian devil.
So how does a species even function like that?
Well, the analysis visualized it perfectly. Imagine their DNA, their genome, is composed of 93% homozygous stretches.
Which means what exactly?
Think of DNA as having two sets of instructions, one from mom, one from dad. In a diverse species, those instructions are a little different. In a cheetah, they're identical copies nearly 93% of the time.
And that has devastating real-world consequences that you can see.
Oh yeah, especially in fertility and immunity. Male cheetahs have a sperm count that's about 10 times lower than other cats.
And of the sperm they do produce.
A staggering 70 to 75% of it is malformed. Tiny heads, giant heads, coiled tails. These are classic textbook signs of severe inbreeding.
And then there's the immune system. We already talked about the skin grafts.
Their MHC genes are nearly uniform, but it gets worse. The genome analysis showed that 4 of those critical immune system genes have been completely disarmed. They become pseudogenes.
So they're just turned off, useless evolutionary relics.
Exactly. This sounds less like a successful predator and more like a biological time bomb.
And that bomb went off in 1983, when all this theory met a very harsh reality.
The infamous feline coronavirus, or FCV, outbreak in a U.S. breeding facility.
Now, in your house cat, SCV is usually not a big deal. The mortality rate is, what, 1%?
About that, yes. It's manageable. But remember, the cheetahs are all immunological clones.
So the virus didn't have to learn a new trick for every new victim.
Precisely. The genetic uniformity was the virus's best weapon. The source material explains that within just 6 months, every single cheetah at the facility was infected. The strain that beat the first cheetah's immune system had the key to beat all of them.
And the final toll.
Within 3 years, 60% of the cheetahs were dead. It was this terrifying real-world proof of just how dangerous their genetic situation really is.
Okay, so given all of that, the crippling genetics, the fragile immune system, the question is, why are there still cheetahs? Why didn't they just go extinct 11,000 years ago? It's a huge contradiction.
And this is where you see the radical evolutionary trade-off they made. The theory is something called genetic purging.
Genetic purging.
Because those bottlenecks were so extreme and went on for so long, the most lethal, harmful recessive genes, the ones that cause, say, severe birth defects, were forced out into the open.
So because all the cheetahs were so similar, if a bad gene existed, it was much more likely to show up.
Right, it was expressed in the homozygous state. Those severely flawed individuals would have died off very early, and they never passed those bad genes on.
So the species basically cleansed its own gene pool through catastrophic loss.
They paid a massive genetic debt up front, over generations. And what was left behind was this streamlined, yes, incredibly fragile, but weirdly perfect gene pool.
Perfect for one thing.
Perfect for speed. The bottleneck didn't just strip out bad genes. It acted like a master lock, permanently fixing the genetic code for this super gene package that defines a cheetah.
And we can see evidence for that now.
We can. That 2015 genome analysis found clear signs of what we call selective sweeps. Basically, flashing red lights in the DNA that say natural selection acted here, and it acted fast. They found 11 candidate genes, all focused on running.
Let's pop the hood on this thing. What are those genes actually doing?
They're all about explosive action and recovery. 5 of them are for muscle contraction and developing specialized muscle fibers. That's your hind limb power right there.
The engine?
The engine. Another 4 regulate catabolic processes, which you can think of as the supercharger. It's about turning nutrients into energy instantly.
And the last 2?
The final 2 are critical for handling the extreme stress of the sprint. When a cheetah hits top speed, its body temperature skyrockets. Those genes help it survive that toll.
So that's why they look the way they do. The non-retractable claws for traction, the huge nasal passages for oxygen, it all connects back to this genomic perfection.
But that hyper-specialization comes at a huge cost. It reinforces how fragile they are.
Because that 30-second sprint is everything they have.
That's it. They can only keep it up for about 500 meters, and afterward they're completely exhausted, overheated, and deeply vulnerable.
Which leads to them losing their kills.
All the time. It's called kleptoparasitism. They lose their meals to lions, leopards, hyenas, just because they are too spent to put up a fight.
Yeah.
They are built to kill fast, but not to fight afterward.
This completely unique genetic background made the cheetah the fastest, sure, but it also led to another paradox. its really strange relationship with humans.
It's a species that's famously easy to tame, but completely impossible to domesticate.
And that distinction is so important.
It's everything. I mean, for a large cat, cheetahs have a remarkably friendly, non-hostile nature towards people, and ancient civilizations noticed this.
They were used as hunting leopards, right, by
Right.
the Sumerians, Egyptians.
And later, it became a huge status symbol for nobility in India and the Middle East. They were these prized hunting companions.
And the training process sounds painstaking.
It was. It took a long time, up to a year. It involved weeks of just careful tethering to get the animal used to people. Then they'd be trained to ride on the back of a horse, hooded, until it was time to hunt.
Basically a trained athlete.
Exactly. But here's the thing. Despite thousands of years of close contact, they never made that leap.
The leap from a tamed wild animal to a domesticated species like a dog or a cat, why not?
Because true domestication requires selective breeding over generations and generations. And you can't selectively breed an animal that won't reproduce in captivity.
It all comes back to that genetic debt, the low fertility, the bad sperm.
That and their very specific behaviors. The most famous example of this failure is it's mind-boggling. Emperor Akbar the Great in 16th century India
He's completely obsessed with that.
kept something like 9,000 cheetahs over his reign. 9,000. And he tried, on an almost industrial scale, to set up a breeding program.
And for all that effort, all those animals,
He reportedly produced a single litter.
just one successful birth out of 9,000 animals, that failure rate is astronomical.
The problem was largely the females. In the wild, they're solitary, they need huge territories, their whole reproductive cycle is very sensitive, it requires a lot of space, specific courtship behaviors, things that traditional zoos just couldn't replicate for decades.
So until modern science figured out how to help them breed, every single cheetah in captivity was just plucked from the wild.
Essentially, yes. Their hyperspecialization didn't just apply to running, it applied to everything.
So where does that leave the cheetah today? We have this incredible creature, this perfect running machine, that's carrying the weight of a near-extinction event from the Ice Age.
The cheetah story, starting with O'Brien's work in the 80s, really did revolutionize conservation science.
How so?
It showed us that genetic loss isn't just an abstract number. It's a real functional limitation. It affects fertility, immunity, the ability to adapt. Their vulnerability to a single new disease is, well, it's extreme.
But despite those dire predictions back then, the ancient bottleneck isn't the only problem they face now, right? Their low numbers today are mostly our fault.
Absolutely. The species is listed as vulnerable. There are only about 6,500 left in the wild. Habitat loss is devastating them, forcing them into conflict with people.
And there's the illegal pet trade.
A huge crisis. Hundreds of cubs are smuggled out of the Horn of Africa every year to markets in the Gulf states.
But that same genetic research is now guiding how we try to help them.
Exactly. Take the reintroduction of cheetahs to India, which has been really controversial.
Because they're bringing in African cheetahs to a place where the Asiatic subspecies went extinct.
Right. But the only reason that's even considered justifiable is because genetic studies confirm that the African and Asian populations are so closely related, stemming from that same shallow gene pool. For conservation, they're basically interchangeable.
The irony is just.
Nice.
It's incredible. The species survived near extinction by purging its flaws and locking in its greatest weapon speed.
But now, that very same specialization, that genetic fragility, leaves it completely vulnerable to the slow, grinding pressures of the modern world.
The cheetah's entire being is optimized for a spectacular 30-second burst of glory, but its long-term survival is a marathon that now depends entirely on us. Will humans, acting as the species' evolutionary surrogate, succeed in protecting a creature whose success was built on being genetically fragile? The future of the world's fastest animal now runs on human will and genomics, reminding us that sometimes the very thing that makes a creature so unique is also its greatest risk.